I forgot to click. I just hit record and not record to cloud. Okay, sorry, folks. Yes, work group device management. Second meeting. We're going to talk a little bit about. We're jumping into the requirements. We covered some administrative logistics already. Sorry, I'm having trouble. Can you link that document into here, Patrick?
Yep. So I noticed that this document that you shared references the NVIDIA use cases, but not the more general document that we had from multiple different parties. I'm not sure whether it was intentional or just overlooked, but we do have this other earlier Google Doc where people were kind enough to contribute use cases. So we probably should consider those and
we definitely
go back to those folks to see whether they want to add it to the new document or copy something.
So what we had, so that's a good, thank you for that. That should be in here too. I guess the goal of this is to try and consolidate and get one place where we have those. And like right now they're scattered across several documents. So I don't know if that means, even if it's just an index into those other documents, that's a good start. Ideally, we'd probably gather them all in one place. I don't know.
Yeah, I think one of the challenges, so when Patrick put the first document together, the reason I didn't put it all in there is because mine was so long.
Yeah.
It felt like it was dominating the rest of what was in that document. So I instead just created a link and put it out to the GPU use cases. So it feels like maybe if they're short enough, put it in this document, but if it's a longer, elaborate set of use cases, then create a link. Might be more reasonable.
That sounds fine. My goal is to get to like the way that I see this working, right, is we have a lot of different people and a lot of different types of users, a lot of different, we have vendors versus users versus whatever. Like, but eventually it has to boil down to an API that has a certain level of expressiveness, right? And some models on the capacity side and some models on the claim side and some scheduler logic to put them together, right? And some auto scaling logic and whatever. So trying to take that wide variety and find the API that's going to be expressive enough is really the main goal. So, trying to, I don't know, make it digestible. Yeah, I don't know, Kevin. I think that's probably the best we can do. I'm just wondering if we should summarize the use cases or if we should, I guess here's where I'm going with that is, how do we iterate as a group on here are all the concepts, here's an idea, like you have your prototype for partitioning, I have the prototype on the APIs, we're going to put those together, so we'll have one expressive API. Who's going to take the time? And it can be me and you and Patrick or whoever. I'd love it if some other people could contribute, take the time to say, hey, here are my use cases. Here's the prototype API. How do I express my use cases in that prototype API? So that's where I'd really like to be in the next few weeks, that we can take all of these different use cases and we can determine how we may or may not be able to meet them with whatever prototype we have.
Just one comment. Let's not forget that we do have an API. It's the current DRA API that as it has been implemented. Some of these use cases should be possible with that API. So sure. we need to map for these use cases against what we currently have to see whether it fits, against what we might have instead to see if they still work. And then we can pick, or then we can decide about changes that we want to make to the current API to make it better for the use cases that we care about. So that's the iterative approach that I would like to see. If we start from scratch and just look at use cases that are now in that document, we are ignoring basically all the previous discussions that we already had around use cases. That's a bit my concern. It's clearly not a complete document. It's just that what people now added, but it's not everything that has been discussed before because people have not re-engaged yet.
Right. Yeah, I agree. We need to have all of the use cases, not just the new ones. I think that the hesitancy I have is I think that the decisions we've made on the API that's in 130, the API that we're prototyping right now is an extension of that. So it's sort of like we do have that question of classic DRA versus the 130 structured parameters DRA and what we can cover and how we might extend structured parameters to cover the additional use cases. So I guess I don't think I don't know that there's value in going back and trying to fit all of the existing use cases into exactly what we have in 130 when like Kevin's work on partitioning, we know we're going to need to do that, right? So the eventual API in 131 is going to be a little different than what we have in 130, and we already know some of those differences. That's my main point.
Yeah, I think that's what's driving the changes that we need to make. We look at use cases, we identify changes that are required because of those use cases,
Yes.
and we decide whether we want to make those changes and how they fit into the current design.
Yes, exactly. Agreed. So, but what we have to do is sort of iterate on that, right? So you're right. We start with the one we have. We already know there's certain extensions we need. And so we can take that step, but then we can say, are those extensions sufficient to cover these other new use cases or the old ones?
Yep.
Yeah. And I'm asking for help, I guess. My point is we need help in two ways, right? We need help with one, enumerating those use cases, and we've got a good start of that here. But two, we need help in evaluating those use cases against the iterative output of our design process. And so I'm trying to encourage anybody to, right now the discussion has been mostly you, Patrick, and Kevin, and me, and Tim. And I'd like for that discussion to broaden to some more folks. And I think as we get the working group repository out there, I think we have an opportunity to do that. That's what I'm trying to get at.
Yeah, one thing I'll throw out there too is that, at least the way that we structured things in 130 with this whole notion of, right now we have the named resources model, and in the future we could extend what a resource, what's it called? What's the top level struct called? A resource model or something? Right now we've got the named resources embedded inside that, but in the future, in theory, we could have a completely different model that the scheduler knows how to process, that we develop based on new use cases that come up that we never thought of, right? And so in my mind, it almost makes sense because we know very concrete use cases right now, GPUs and networking. I agree that we should gather all of these use cases, but I'd almost rather focus on enabling GPUs and networking first, with the ability to expand, our resource model with a list of other resource models that can meet our other use cases in the future.
Yeah, we talked about this last time, and I'm very hesitant to have completely different models that have to be understood by people. Like I would prefer to have a composable model that you can use less of it if you want, but you can add more to it.
So I think we want the same user-facing
yeah.
API, but the vendor-specific one, I think not only do we can it be different? I think we want it to be different because different vendors have different ways that they want to present their hardware.
That's fair. I'm skeptical you can have the same user-facing API, but that would be awesome, right? I'm totally game for that. I'm mostly game for that. It is a lot of work to build a scheduler and autoscaler to understand those different models. So
yeah, adding a second model should not be done lightly. I fully agree. But we need to be prepared to have, but we might have to do it eventually.
Yeah. Okay. I don't want to rattle on this. We've got a lot of people on the call, and I want to make sure that we're using everybody's time.
One more comment about what you said about mapping use cases to the current thing. This really needs a champion for some specific use case. Ideally, someone who is also willing to do some prototyping or DRA driver development work to actually turn that into reality. It can't be just a user who says, I wish someone did this. We need to have someone who does it. And that's how we got this far with GPUs, because we had people who were trying out this concept in reality with real hardware. And we need to get to the same level for other use cases. Otherwise, it's just discussions.
So along those
useful-
lines, Patrick,
Useful, yeah, but
I did put this in here. So
Yeah.
part of our goal here, right, is by beta, in order to reach beta, we need at least 2 vendors to have implemented drivers. You know, and we have NVIDIA. I know we have existing DRA drivers on the existing classic DRA functionality, but like, Patrick, are you gonna, or somebody at Intel gonna build some drivers for some of your devices? Like, do we have other device vendors that we had a list here of folks? You know, some folks from AWS, some folks from Google. Like, can we get commitments from folks to build out drivers?
there is a commitment from the Acrino folks who want to do a driver for network IP cameras. That's open source. It's not a hardware vendor, but it is using DRA, or it will be using DRA. So we can add that.
Is
If we
that-
think
Who was that?
Do we have them on the call to, is that how I spell it? How do I spell it?
I think it is spelled like that. I need to look it up. I can add a link.
Okay. I'll just put that down.
You can enlist me for the multiple interfaces, multiple network interfaces.
Is this what you're saying? You're gonna
Yes.
work on a driver for, yeah, okay. Awesome. Yeah,
Do we
that
have
would,
folks from, sorry. I was wondering if we have folks from AMD as well, like another GPU flavor. We can check. They've been showing up at Signode.
okay. So Runal, can you,
Yeah, I can follow up. Yeah.
excellent, okay.
So we can do for AWS and then work with some collaborators.
Your sound.
Okay, is this better?
Well, maybe,
Okay, better. Sorry.
oh, much better, yes.
I think you can put me for AWS. I'm part of AWS. I just have to talk with Gita, who's the owner from our side. Thanks.
Okay,
What devices are you interested in at AWS?
Trainium. And I mean Trainium for accelerators, EFA for network.
okay. That's fantastic. Okay, so yeah, so if we can get, so I guess what I would ask then is both, so this is this specific item I was asking about were the drivers, but we're also gonna need your input into the actual prototype models. So I'm wondering if normally we do this meeting every other week. I'm wondering if next week we should do this meeting at the same time, and we should go, or at least for the subset of people, and go through like in depth. Here's, because by then we should have it nailed down, the stuff that we're proposing, the prototype, and we can show some examples of how the user would make a claim against the resources and how a vendor would present the resources. And then it would be great to meet with maybe those 2 groups. So the Abhishek, I think you're here, you are representing the end users, leading that effort, and actually go through and say, okay, like I reviewed the sort of claim API with some folks here yesterday that we've been talking about, and they were like, this looks way too hard for users. Like, can we push more into the class or whatever, right? So like there might be good feedback from end users on the claim side. There might be good feedback from vendors on the capacity side and whether the model is sufficient for what you need to do. So we could go into that now, but it's pretty deep. I think it's probably better to have a smaller crowd because not everybody's going to be interested. And plus, it's not quite ready yet. Like Kevin has something and I have something, but they're not merged together and all of that, and they're not complete yet. So, any objections to that if I set up another meeting for 1 week from now with okay, awesome. With that focus. I guess I can put it in the notes here. Okay. Okay. So what I was thinking next, so we talked about gathering these requirements. We have those different folks on here. I think that Neha and I, we were chatting before the call. We'll try to reach out to the different people on this list over this week and try and develop out that document more, and that will help us get a more complete sense of the use cases. So that's another action item. Gosh, sorry. That's different, Neha. Okay, I'll just figure that out later. Okay, so then what I was thinking we can do next, if people think it's it's valuable, was start to look at what we've done so far in that regard, not into the details of the model, but into the way we're structuring the requirements. Kevin, did you want to maybe at least explain what this is for now before we go into that, or?
I can, sure. So I put together so if you remember, if you've watched and read some of the documentation on how DRA has changed over time into becoming this thing that we call structured parameters model, which allows you to, at least at the device vendor level, it allows you to kind of advertise all of the resources that you have available through a well-defined API now, which we call a node resource. And the scheduler is able to pick that up, look at it, know what resources are available so that when a request comes in from an end user, it can basically allocate those out to the end user the same way it would with what you do with the device plugin today, where the main difference between what we have with DRA and what you can do with the device plugin today is that the device plugin today kind of follows a two-level scheduling approach where all that the scheduler knows about is how to count the number of resources that are available, but the actual allocation of those resources is left up to the kubelet once a pod that's consuming those resources lands on the node, right? So, if you think about the way the device plugin API works today, I have a plugin that I start up. It advertises all of its resources as opaque strings back to the kubelet. Kubelet keeps track of those opaque strings as individual resources that can be allocated out, but all that it advertises back to the scheduler via a field in the node object is the number of resources that are available of a given type. So when you come along in your pod spec and say, I want 2 NVIDIA.com GPUs, all the scheduler does is when it decides that it's going to give you those GPUs, it subtracts 2 from what's available on that node, schedules your pod on that node, and then the kubelet is in charge of actually making sure to figure out what exact GPUs you get given before it launches your pod on that node, right? DRA flips that around where all scheduling decisions are now made in the scheduler by design so that when I have a kubelet plugin that's running, a kubelet plugin as part of my driver rather than as a device plugin, it's going to advertise all of these opaque strings in a similar way that we do with the device plugin today, but it's going to advertise for the scheduler to be aware of those. And instead of just having an opaque string that represents each resource, there's also a set of attributes that hang off of that. So that individual device selection can be done rather than just, based on those attributes, rather than just treating every single resource that's being advertised by that plugin as equal, right? And so what the scheduler is able to do is when you put in a request for a specific type of GPU now, it's going to be able to say, okay, what are the attributes that they want from this GPU that they've advertised through this API? And I'm kind of ignoring what that API from the end user looks like. But once it hits the scheduler, he's able to see, okay, some type of GPU with some attributes is being requested. I'm able to now look into this node resource object that's been published by the plugin that's in charge of those resources, do some match on that, and then figure out exactly which device I'm going to allocate for your pod to run, right? And in the initial implementation of what we did with structured parameters, all we have available is the notion of an opaque string representing the device and its set of attributes. And that's very limiting in the sense that every single device can only be selected on those attributes and you have to hand out that full device. And what we want to be able to do in the next release of Kubernetes is to be able to not just allocate full devices, but also allocate partitions of those devices. And so, in the case of NVIDIA GPUs, the technology that allows us to do this is called MIG, which is what I've mentioned in my comment here in the notes here. Is we want to be able to be a way to be able to say, I want to request either a full GPU or some of the different MIG devices, some of the different partitions that can exist on this device. And I want to be able to do that fully dynamically, right? I want to be able to say, let the scheduler decide what subset of this GPU am I going to actually hand out based on the request, and make those divisions possible at runtime rather than having to make the driver pre-partition them and only make some subset of them available for allocation, right? And so the model that I put together here, this prototype, allows us to do that, right? And I don't know if we want to go into the exact details of what I did to extend the existing
I think we'll leave that for next
parameters model that
call.
we can leave that
Yeah.
for the next call, but that's the basic idea. And so I encourage, if anyone's interested in exactly this, what I did and how you can actually extend one of these resource models to support something like this, I encourage you to click on the GitHub link there and go through what I've done to enable this. And as John said, this is
was
my
a-
prototype for how do I extend the structured parameters model we have today to support this. And now we're kind of backporting that into his entire overhaul of all of the abstractions that we're trying to do and making it work in that. Yeah, Mrinal, you have your hand up.
Yeah, I haven't looked at the code yet, but at a higher level, are we gonna expose all possible partitions, and then the scheduler will pick this or this or this?
Yeah, I mean, at a very high level, the way you can think about it is instead of just enumerating the top level GPUs, you'll now enumerate the top level GPUs and all of the possible MIG devices that could ever be created on any of those GPUs. And what you do, and then in addition to all of that, at the very top level, next to the list of instances, as we call them, that can be created, all these different devices that can be created, there's also now a list of shared resources that can be consumed by any one of those devices. And so the way that it will work under the hood is on a given GPU, there's a maximum amount of memory that can be consumed. There's a maximum number of JPEG engines that can be consumed. There's a maximum number of encoders and decoders that can be consumed. There's a placement in terms of memory slices that are consumed by any one of these individual devices, right? Every single MIG partition or full GPU will advertise what subset of these things it consumes. And then when the scheduler sees this top level limits and it's trying to match that to what can actually be allocated in real time, and then when it actually does that allocation, it will subtract that from this higher level limits of what's being consumed by any one of those, such that it'll know that it can never actually allocate two overlapping devices because they'll end up consuming more resources of a given type from that shared set of resources than is possible.
Yeah,
Does that make
we'll
sense?
go over this. We'll go over this with code next week. I think that Abhishek.
Yeah, so I mean, I'll park my question and ask next week. Maybe that's going into too much of the
It might be
detail.
going into too much detail for today.
Yeah.
But again, I encourage you to click
Kevin's
on there
explanation
and
of
look through the code and
yeah, exactly. So Kevin's explanation of the whole process was great, and of his specific extension was really good too. But I know it's probably deeper than most folks are prepared to accept on a call without going into it. But essentially, exactly what Kevin said. The idea is like you do enumerate all of the possible ones, and you also keep track of when you allocate one of those, what does it do to the overall available capacity on that card. Along those lines, so exactly what Kevin's describing, we've tried to kind of break out into a set of requirements. And with the context of what Kevin said, you might these requirements might start to make more sense. Like, and so if it's, I'll go over what we're thinking right now. And this is when I was talking earlier about like we're going through all these use cases, we're trying to boil them down to a smaller set of requirements that are like the requirements on the APIs. This is what I'm trying to get to. I'm trying to get to this set of things that can be implemented from the broader set of use cases. Olivier?
Yes, so just a quick question there in terms of any, sorry, can you hear me?
Yes.
Yes. So I have a question in terms of scalability of this model, right? Any thoughts about that, right? Because it seems to assume that there's only a few resources in the GPU, or in the dozens, maybe 20, I don't know, something like that. What if we grow this number of resources? Any thoughts about that? These base resources that then the partitions range over.
yeah, one thing that I'll comment on. Sorry, John, let me just go to the side. Is that
Go ahead.
there's a limit in etcd as to how many megabytes you can actually produce in one single object. And so one way that, and then in what I produce for an 8 GPU machine with all of these possible NIC devices, I already go way over that megabyte limit, right? And so one thing that we've allowed in the model as we put it together today is that a single node can create multiple of these node resources, and the scheduler will pull all of them together and from different instances of the object in the API server, right? And so the way that my driver will actually, assuming we do exactly what I've put in this prototype, what the driver will end up doing is that I'll have a different API server object for each GPU and all of its MIG devices, and they'll be put in under the same resource slice, and then the scheduler will be able to resolve all of them and pull them in as necessary. I don't know if that fully answers your question, but at least it answers maybe how we can break these up and actually have multiple objects in the API server rather than just one giant one that has to govern all of the resources from a given driver.
Okay.
John,
Okay.
it looks like you were going to say something too.
Yeah, no, that's great. Yeah, and that's exactly like we, yeah, that's fine. That was a good answer. Thank you, Kevin. All right, so in general in the model, and we'll go into the details of this next week, but in general in the model, like many other APIs within Kubernetes and like the existing DRA, we have the idea of claims and classes. So classes are administrator created, therefore they're cluster scoped, and they're reusable by different users. Users create the claims. Claims are namespace scoped. So a claim is a request for some device or a set of devices. And within that claim, you can express configuration of that device. That's one of our requirements. Within the class, you can express configuration of the device. You can express constraints for how to select the device. So I want this vendor, or I want things managed by this driver. I want this model. There can be other kind of constraints. The claims refine the constraints of the class. So that's kind of the basic model that on the user side. On the vendor side, you're populating what we call resource slices right now, but we are, I call them device pools where we still haven't agreed on naming. So when you look through these requirements and you try and look at what as we look at our different use cases and we try and boil down those use cases into a set of what does the model have to support? How expressive does the model have to be in order to meet that use case? That's the context I want you to have in mind. Are those three basic things: classes defined by administrators, claims that reuse classes in different ways, and then capacity that's published by the vendor. So on our prototyping, and really, I guess probably these are really more as far as we see it right now, the requirements likely we have for 131. Obviously, we need device classes. They have to capture the configuration and selection constraints. We need claims that allow them to choose a class and then further refine the selection and add additional configuration. The way we're doing it, we want to be able to pull in like CRD, vendor-specific CRDs and things like that. So you need to be able to pull in arbitrary objects. These are as far as we can see from our existing use cases, these are the ways in which we need to be able to provide selection constraints within classes and claims, static metadata about the device, like I said, a specific driver, which is really kind of implies, you could probably get that out of the static metadata, so maybe we don't need that as a separate thing. So this is one we don't, as far as I know, have in the existing DRA, but I think is important. It's not important for GPUs, but when we start looking at the network use cases, it becomes more important. So with networking, like something like SR-IOV is sort of a well-understood thing across vendors, and the semantics of it are the same across vendors. And so as a user, I don't want to say, a driver is generally going to be vendor specific. So as a user, I don't want to have to say, I need an SR-IOV virtual function, therefore I need an Intel SR-IOV virtual function, or I need a Mellanox SR-IOV virtual function, or I need a Google NIC with an SR-IOV function. Like, what I want to be able to say is, I don't care what SR-IOV virtual function gets provided by the infrastructure, I just want an SR-IOV virtual function. So we added this additional requirement for like a generic type. And then we need to be able to, sometimes we need to select, one device isn't sufficient. We might need to select multiple devices at once in a claim. This is the must-have section. We have more nice to haves. So right now, just like device plugin works today, it's exclusive whole device consumption. So basically, when you consume a device, nobody else can consume it, and you get the whole device. So we need to at least support that. This is another concept that NVIDIA supports today in the existing DRA driver, but I don't know that anybody else does, but this is the idea of monitoring workloads. So I want to run a daemon set on all of the nodes with my cards, and that daemon set is going to gather metrics or do some management services. I don't want to mark the card as consumed, but it's still available for users. This is another thing. So we're trying to figure out how to do that. We've had a few different, the problem is that has to be RBAC'd differently, or it has to be managed differently by quota. So it becomes we can't just use the regular, we may not be able to just use the regular claim object. So that's some of the challenges we have trying to implement this within the Kubernetes API infrastructure.
Yeah, as a general mechanism, I think is the challenge, rather than something.
Rather than a driver specific one.
Driver specifically. Yeah.
Yes, yeah. Dynamically partitionable devices. This is what Kevin just went into. we believe that's a must-have in 131, right? For you, Kevin, that's a must-have, correct? All right. Multiple claims satisfied by a single node. So here the idea is we need to select both a GPU and a NIC that come from different vendors. So we need to be able to express within a pod spec. Typically, those are going to be different claims, although that's a different, well, in the current thinking, those are different claims. And so in the pod spec, you have to be able to specify both of those claims, and they both have to be satisfied. And I believe this came out of the discussions last week or 2 weeks ago, propagation of actuation failures from the node to the control plane. So if there is a problem with a card on a running pod or even before it gets to a running state, rather than just saying pod failed, like we can actually propagate error messages from the individual cards and put them somewhere where you can find them in the control plane. This comes down to scoring different options to satisfy a claim, meaning I'm going to enumerate all those possibilities like Kevin was talking about with the MIGs, but really that goes across all of them. You have to enumerate all the possibilities. This is a big challenge in the scheduler because you can see there's a combinatorial effect. So we have to figure out how to do this efficiently, or prune that tree quickly. So this gets back to this constraints where we can say, hey, I want that NIC and that GPU, but I want to make sure they're contained on the same NUMA node or the same PCI root complex. Like we want to be able to put some constraints on them. The other place where this is valuable is I want these two partitions, I want from a MIG, but I want them on the same GPU. One question I had to our end users or our vendors is there a use case for I want these satisfied, but I want them on different? So just like we have affinity and anti-affinity for pods. So the one I thought of that I wasn't sure if it was valuable or not is I'm building a networking pod that needs say 4 VFs or just say 2 VFs, but I want to put them on 2 different PFs. I want to put them on 2 different physical NICs for redundancy, right? So for failure management, or because I'm going to bond them, or maybe I want 2 physical NICs. Forget VFs. I just want 2 physical. Well, and I want them on the same PCI route, like, or I want them on different. I don't know. You get the question I'm asking. Is there a use case for anti-affinity, not just for affinity? And so, anybody have any thoughts there before I continue?
I would imagine there are. I'll just leave it at that.
Yeah, I'm trying to do concrete use cases, but yeah, I imagine there are too. All right, so I'm going to put a note here. Do we have a need for anti-affinity? That is, select these 2, for example. These 2 VFs, make sure they are on different PFs. Okay, so that's as far as, and I don't know that Kevin and Patrick have reviewed this in detail like this yet, so they may disagree. And obviously, all this is trying to come to consensus. That's, from my opinion, the minimal things we need to get into our prototype, which translates into the minimal things we need to support within the 131 timeframe. But there are some other things that I think we're likely to be able to get to as well. So in particular, this this is actually one API can satisfy that, as well as this next one, which is a super interesting one. This one in particular, actually, this solution. So the idea here is we've heard from some of our users that with their workload, they'd love to get an H100 or an A100, but if they have to take two L4s, they'll take it, right? So this is a sort of prioritized list of how you might satisfy a claim, with the expectation that with whatever gets chosen by the platform, the workload will adjust, when it wakes up to accept the devices it's been given. So I'm going through all of these with folks here because I want feedback on them. So please raise your hands or put things in the document as we go through it. So that's what this. That's an explicit statement. I want this, or two of those. Another way to do that is I have a workload with that requires 24 gigs of GPU RAM. So just give me a share of a device. It could be a MIG partition. It could be a whole device, because we can't split them. Or we could add later the idea of partial device consumption. Like I can regulate the amount of workloads I schedule to a given device based upon some resource requirements that they've specified. This looks very much like what we do with ordinary compute and nodes, right? We can say a node has, this much CPU or this much memory. When we get requests, we will reserve that memory that we schedule that pod to. We can do the same thing with devices. I don't know if we need to do the same thing with devices. It looks like we have a hand. Olivier?
Yes, since you're asking for comments, this is really important, but it's not clear this needs to be solved at the DRA level, right? As opposed, for instance, for, in a batch scheduling system like Q, make decisions beforehand based on quotas, and say you have a certain quota of A100, you have a certain quota of L4. At that point in time, the decision will be made on whether or not, which one of the two you're going to get. And, so is this really it's not entirely equivalent as solving this problem in DRA, but does it needs to be pushed down all the way to DRA? It would be my question here.
Okay, I think that's a valid point. All right. I don't know how the hand ordering works. So if you think you're first, go ahead and start talking.
So some of the sharing of a whole claim between pods, that used to be a highly important use case for classic DRA. Kevin, perhaps you can share more about specific application workloads that needed, because now it appears under nice to have, and I think that's a downgrade from what we considered for this use case in the past. And the other thing about partial allocation, I think I've not seen any real world use case for that. So perhaps that one might, well, it's definitely nice to have, but certainly wouldn't prioritize it as a, it's not real at this point. It might be some future extension or some future need.
I think it's not enforceable on most of the devices, so that makes it not really that real.
Yeah, I think my hand next. I wanted to comment on this, like whether this is DRA job or non-DRA job. We need the same for inference. When inference is scheduled, and we also want to work on some leftovers of devices, like whatever is left, give me that. And to implement that, we need like end user to specify somehow the ordering, and we cannot repeat the same ordering specification in batch one way, in inference another way, and then another solution will come. It will be like yet another way to express the preference for workload, how to run. So that's how, that's an argument towards DRA implementing that. That said, I have another question, and it's maybe like related to Patrick's question. Like, how much customization customers, like end users, may want to have when they have different devices? Like, do they ever be needed to run different images? Like, modified images, like different environment variables or anything. So how much I just don't know enough and haven't heard too many cases like that. Like, if anybody knows how much customizations are needed by end users, can you comment on that?
For which piece? Sorry, I missed something in what you said.
For if I want to specify like either this GPU or that GPU class, how much customizations end users may want to have in terms of like extra environment variable setup or extra like different code bias is taken, like something like
I
that.
think the question is, like I said, the workload wakes up and says, oh, this is what I got, I'm gonna use it. Is that feasible? What is the need? Like, does that workload need a different image? I mean, obviously, if you gave it a completely different vendor's GPU, it couldn't run, right? Like, so
You're saying you need some way of discovering what it was actually given inside the workload itself.
yeah. And I think Sergey's question is like, what is the extent of that typically? So Sergey and Patrick, can you comment on the document? Because it's hard for me to capture your notes and talk at the same time. Thank you. But does anybody have any thoughts on Sergey's question?
I'll just say, at least until now, at least on the GPU side, we treat most of the things, if you ask for something, if you want something specific, you have to ask for it. If you want something general, then you just need to make sure that CUDA workload can run on it, and that's what we'll give you. You don't necessarily need to be informed of what you're given, because we'll only give you something that it's either, say, either a MIG device or a GPU. If you know that what you're going to run on it could run on either without needing to discover that. But I get your point. Like, in general, if you have the potential to get X, Y, or Z, apples or oranges, then the workload's going to need some way to know, well, which one did I get, so it can react to it. And I think maybe the question is around, how do we standardize that, or is that even something that we need to worry about at all?
I think the question is it useful to even implement that in DRA if the workloads can't take advantage of it? That's
Right.
my read of the question.
I see. Yeah.
But it sounds like, at least in the NVIDIA case, as long as you're not like, give me, as long as you're saying, as long as your three choices are three different NVIDIA GPUs, generally your workload's probably fine.
Yeah. As long as they've written against the CUDA API, whatever we give you, if it matches the constraints you've asked for, it will run them. Yeah, without you needing to discover it.
Abhishek?
Yeah, I understand that part. So if you configure it claims correctly that everything works, but I wonder how much people will need to have like very drastically different fallbacks defined and how they will implement it.
Yeah, I mean, one thing that I could think about is, I mean, just bringing this case out. Imagine if you said you need X amount of GPU RAM, but then you get a mixed slice, and in that scenario, maybe today nickel is not supported, and user was expecting a nickel device. So in that scenario, it might affect the workload.
So I don't know what that is you just said. So, but is that the sort of thing, Kevin, that would be in the attributes as something the device supports, or is it too fine grained for that?
I got distracted for a second. Can you repeat it, Abhishek?
Yeah, I mean, I was just mentioning a user specifies just X amount of GPU RAM, and maybe his intent was to acquire the whole GPU and use the nickel protocol, but instead of that, he gets a slice of an H100, and maybe in that scenario, nickel is not supported, and the workload may fail.
Yeah, so I think by default, the way I'm expecting to be able to do this, give you either a MIG or a full GPU, is that unless you specifically say, I don't care which one I get, we're going to give you a full GPU. You would need to actively say, I'm fine with getting either. because you know that the workload you're going to run could run on either one. Again, I don't know how we're going to do that, but that's what we do in the current DRA, classic DRA design. That's how that works.
Okay, so we should think about that, Kevin, in our like prototype. There must be, well, yeah, I think you have an attribute saying whether it's a MIG device or not. So
Right now, I
you
have
know,
an
if the thing-
attribute that says, am I a MIG device or am I a full GPU? And because we generate the cell expression, at least in the current incarnation of this, when someone creates a GPU claim parameters object and asks for something, I always put type equals GPU, so it's only going to match full GPUs. If you ask for a MIG device, if you specifically ask for a MIG device, I put type equals MIG. And then there's a field in our vendor-specific claim parameters object. I haven't added this yet, but I could, that says, I don't care. And now I won't set the type and it'll give you either one.
Right. And we could capture that in a class too, right? Like, right, a
I'm not
class.
sure, maybe. Yeah, you could have like an I don't care class. I don't know what name we would
Yeah,
give
it would just say MIG or full GPU or something like that. in
Yeah.
this sentence, right? So-
Yeah.
Sorry, we're running out of time. We have two hands up. Patrick, I think, was first, and then Clayton.
I was about to say that we are running out of time, so the more we discuss the use cases now, the less we get to go through the remaining agenda. I wanted to ask what we do about the CAP refactoring. I've prepared it so that we can and should, that was my thinking, that we merge it now, and then we have a base that we can target with smaller PRs to update the CAP to match what we want to make as further enhancements. But I've not seen much comments on it yet, so I was wondering whether that is a general shared understanding that we should be doing smaller incremental CAP updates, or whether the goal is now to have 1 mega CAP update sometime in the future before the CAP deadline. That includes everything that has been discussed separately outside of the CAP process.
I just haven't gotten to reviewing it.
That's the
so
problem. Yes.
I think you asked. I said I did. Like, I'm able to commit to do it this week, and I think others. Shouldn't be the only one looking at it, but like, yeah, I agree. I think that your basic restructuring is important to get done now, and then what we do after that, we'll have to decide as the time goes on.
That means we need to get it merged, because otherwise people will need to target my branch with that text and we'll get merge conflicts.
Yes, it needs to
wording
merge
changes.
before we start.
It'll be horrible.
Okay, we'll get
Let's
that
not do
merged.
that.
Yes.
Yeah.
Okay. We're out of time, but Clayton had his hand up. I don't know if it's quick. All right, I assume it's not. All right, thank you all, and we'll see you in a week to specifically go through the API's prototyping to meet the requirements we've just been looking at. But please go ahead and start poking at those requirements. I see a bunch of comments in there already. That's exactly what we're looking for. Thank you so much.